Characteristics and first signs. El Niño is characterized by irregularly occurring complex series of climatic changes that affect the equatorial Pacific regions every few years. It is characterized by weakening of the Walker circulation and strengthening of the Hadley circulation. Some first signs of El Niño include a rise in surface pressure over the Indian Ocean, falling air pressure over Tahiti and Central and Eastern Pacific Ocean. Other signs include the trade winds in the South Pacific weakening and warm air rising near Peru, causing rain in the deserts. One of the first scientists to study El Niño, Sir Gilbert Walker, was a British physicist and the Director General of Observatories in Indian Meteorological Department. His predecessor, Henry Blandford, noticed the pattern of the summer monsoon in India was correlated with the spring snow-covered Himalayas. Walker developed his ideas and came up with the correlation and relation equation for El Niño. He analyzed vast amounts of weather data, published the first description of the Great Seesaw Oscillation of atmospheric pressure between the Indian and Pacific Ocean. He also correlated the oscillations to temperature and rainfall patterns across much of the Earth's tropical regions.
How to detect El Niño? One way El Niño is detected and predicted is through the use of satellites. Satellites can be used to measure changes in sea surface level, water temperature, and wind speed. Another method of detection is using moored buoys. Moored buoys can be used to measure barometric pressure and wind speed and direction. It is also used to measure sea temperature and wave height. A third method of detection is using XBTs. XBTs are dropped all over oceans to measure how temperature varies in different regions. Putting together all data gathered from the satellites, sea level analysis, XBTs, and moored buoys, we are able to predict El Niños with computer models.
ENSO has a range of weather effects around the world. Pressure and temperature change around the Pacific, leading to increased rainfall in the eastern and decreased rainfall in the western. ENSO also affects hurricane patterns with decreased activity in the Atlantic and increased typhoons in the eastern North Pacific. Along with that, jet streams and storm tracks are also affected by increased tropical rainfall from ENSO. One region that is particularly strongly affected by ENSO cycles is South America, where there is significantly increased rainfall on the coast and southeastern parts of it. This leads to flooding and landslides in the area, and a stellar example of that is in Peru, where every couple of years there are severe flooding problems and it takes a significant toll on the people and the government. Another region that is strongly affected by ENSO cycles is Australia. Extreme droughts are caused in the region of Asia and Australia because of a huge decrease in rainfall. One particularly strong example of that is in eastern Australia, with an extreme drought which takes a huge toll on the wildlife, fauna, and animals, as well as the people and government in the region.